Hello everyone, welcome back to my YouTube channel. As everyone knows, myself Himavati Ji, I am pursuing my BE graduate in Sri Venkateshwara College of Engineering, Bengaluru. Today's my subject is mathematics and my topic is calculus in image processing. We all know what is mean for calculus. Calculus is a mathematical study of continuous change. Let's see introduction to the calculus in image processing. Calculus plays a critical role in image processing techniques. It helps in analyzing and transforming image through a mathematical operations. Understanding the fundamentals of the calculus is essential for developing advanced image processing algorithms. Let's see what is the role of derivatives in calculus image processing. Derivatives measures the rate of change in image intensity values. They are used to detect edges, which are critical features in images. Edge detection is accomplished through methods such as the Sobel and Laplacian operator. About Sobel and Laplacian operator, we are going to discuss in upcoming slides. Derivatives of in finance. There are mainly three types of derivatives in finance. They are forward contracts, future contracts, and options. Let's move into the next slide, that is the role of integrals in image processing. Integrals are used to calculate the area under curves which can represent the visual intensity distribution. They are help in filtering and smoothing image by the averaging pixel values. Here pixel value means it is a single number that represents the brightness of the pixel. Image histograms can be derived using the integral concepts to analyze the visual intensity distribution. Here are few of the properties of the integrals. They are constant multiplier, which means integration from a to b k into f of x with respect to x, which gives us the constant k into integration from a to b f of x with respect to x. Sum or difference means integration from a to b f of x plus or minus g of x with respect to x, which gives us the integration from a to b f of x with respect to x plus or minus integration from a to b g of x with respect to x. And one more property is reversing the points, which means integration from a to b f of x with respect to s, which gives us the minus of integration from a to b f of x dx. Let's see what is mean for convolution and calculus. Convolution is a mathematical operation that is used in image processing to transform an image by applying the kernel over the image's pixels. It takes two functions, that is f and g, and which produces the third function. In image processing, convolution is a filter operation that takes two images and produces a third images that is transformed by the operation between the two images. Let's see what is meant for gradient and image processing. Gradients are the mathematical functions used in computer vision to measure the intensity change of an image. There are various types of gradient operators used for image processing and analyzing, such as the Sobel, Searcher, Prewitt, and Laplacian of Gaussian operator. Here we can see in this picture, when we gives an image, it gives two components, that is a gradient x and gradient y. Through these which we can get an answer, that is a gradient magnitude and the gradient operations or orientation. Let's see what is Laplacian operator. Template in computer science that implements the second order differencing by computing the difference between a point and average of its four direct neighbors. It is used for edge detection and image processing, but requires the additional smoothing to handle noise effectively. Laplacian operator gives us the partial differentiation formula, that is dou square f by dou x square plus dou square f by dou y square plus dou square f by dou z square, as we all discussed in the class. Let's see next was the image segmentation techniques. Image segmentation is a technique used to separate the region of interest from the rest of an image. It's often used to locate the objects and boundaries in an image. Here are some of the image segment techniques that they are discontinuity, similarity, edge based, under that edge based, clustering based, thresholding, region based. As we discussed previous, that is gradient based and Gaussian based. Under gradient based we can see Robert, Provitt or Sobel. Under Gaussian based, Laplacian of a Gaussian. Let's move into the next slide, that is the Fourier transform and calculus. The Fourier transform is a mathematical operation that uses an integral to transform a function into the another function that shows the frequencies present in the original function. The ft is a complex valued function of frequency, and the output is sometimes called the frequency domain representation of the original function. Let's move into the next slide, that is the optimization of image processing. There are mainly 6 steps of image processing in optimization. They are identity goals, analyzing the current process, decision process optimization, step optimized process, implement process optimization, and the final one was the evaluate and continuous improve. Image optimization is the process of modifying the image to make them load faster and improve the user experiences. The goal is to deliver high quality images in the best format, resolution and dimension for the devices accessing them, while keeping the file size as small as possible. When we come to the last slide, by this slide we can conclude this video, that is future direction in calculus image processing. In integration of calculus with a machine learning is shaping the future in image processing. Advanced algorithms can learn complex patterns and enhance image analysis. Ongoing research is focused on improving efficiency and accuracy in real-time applications. Through this, I can conclude this video. Thank you so much for watching my video. Please do like and share to everyone.